Hello and welcome students to another video class for grade 8th mathematics, and today we'll be starting our new chapter, that is algebraic expressions and identities. So let's begin with this. So what is algebra? Algebra is a branch of mathematics that involves letters for numbers, right? And the numbers are the constants. Then next is variables. So the letters used are called as variables. Then let's move to expression. So an expression contains the combination of constants and variables together with the help of arithmetic operators. We are using fundamental operators of addition, subtraction, multiplication, and division. Then next is equation. So when two expressions are equated together, we get an equation, right? So all these things maybe you have studied and learned in your previous class. So just a quick review of that. The next we have some equations are true for all the values, and such equations are called as identities. So such equations which are true for all the values of variables, okay, included in that equation. So such equations are called as identities, okay. Right. So let's see what we have to learn in this chapter, that is termed as algebraic expressions and identities. So at the end of this video class, you will be able to understand these following concepts, starting with the very first one, identify the algebraic expression, right? Second, we have solve degree of a polynomial. Then third, we have solve monomials, binomials, and polynomials, okay? Then we have identify like and alike terms. Then we have solve addition, subtraction, and multiplication of the algebraic expressions. Okay, so these are the concepts, and these are the key points that we have to understand regarding this video class and this chapter. The last one we have describe identity and standard identities. Okay, so let's begin with expressions. So what basically expressions are? So the price of, for example, let's understand this concept with the help of an example, such as the price of a chocolate is rupees 5 and the price of a pen is rupees 10. So what is the total price of 3 chocolates and 10 pens? Okay, so it's very easy for you. So to solve the problem, we form an expression as, so cost of one pen is given as, let's say it is rupees X, okay? Then cost of one chocolate, let's say it is rupees Y. So cost of 3 chocolates will be equal to what? 3y, okay? And cost of 10 will be equal to nothing but 10 into x, that is 10x. So total cost can be given by this expression, that is 3x plus 10y, okay? So this is called as algebraic expressions, which consist of numbers as constants, and we are having letters as variables, including some arithmetic operations. So in this case, we are having a additional operator, okay? So 3x plus 10y, that is an algebraic expression. So after putting the values over here, what you will get, 3 into 5 plus 10 into 10. So the final answer, total cost, that will be equal to 15 plus 100. Okay, so we got 115. Okay, that is the total cost regarding this problem, rupees 115. So next we have a number line and an expression. Okay, so what is the relation between a number line and an expression, that we'll try to understand over here. So consider the expression x plus 4, and let us consider the variable x take the position capital X on the number line. So what we'll see over here, so given variable is x, which takes the position capital X on the number line. So since all of you can see that since the given expression, the constant 4 takes the positive value, okay? So this constant 4 takes the positive value. So A takes the positive 4 units to the right of X, okay? So if the expression is X minus 4, then all of you can see that the position A will be to the left of X, okay? So in this case, since the expression is X plus 4, so you can see that the position of A is 4 units to the right of X, okay? Similarly, if expression is X minus 4, the position of A will be towards the left of X. So let's take one more example. Consider the expression 5x plus 6, okay? Now you can see that let X takes the position uh, X on the number line. And since the first term of the given expression is 5x, so the position of 5x will be point D. Okay, all of you can see it. Since the one unit over here in the number line is represented by X, okay? So the position of 5x will be 5 times of x. Okay, so we'll keep moving from point O towards point D. Okay, so at point D, the position of 5x will get. Okay, then the distance of D from the origin will be 5 times the distance of x from the origin. Okay, right. So at position D, we are getting 5x. Therefore, the position of E of 5x plus C will be 6 units to the right of D. Got it? So it will be 6 units to the right of D. So in that point, we'll get the position of point E all over algebraic expression, that is 5x plus 6. Okay. Then next we have algebraic expressions. So let's understand one more time these terms. So what is a constant? As you know, that a symbol having a fixed numerical value is called a constant, right? Then we have, for example, you can see 3 minus 5, 9 by 7. We can take any other constant also. Then we have variables. Okay, then we have variables. A symbol or alphabet which takes on various numerical values is known as variable. For example, circumference of a circle C is equals to 2 pi r. Okay, where r is the radius of the circle. Okay, so r can change. Okay, so 2 is constant. The value of pi, here we are writing p, so it is basically pi. So 2 pi r, so 2 is constant, the value of pi is constant, 3.114, and so on. And but the radius of the circle is not constant. It depends on the size. It depends on the size of that particular circle that we are talking about. So radius of different circles may vary. That's why radius of different circles are not constant, they are variables. Okay, then next heading is polynomials. So let's move to polynomials. So an algebraic expression in which the variables involved have only non-negative integral power is called a polynomial. For example, let's see some examples. Uh, One is 3 minus 4x plus 9x raised to the power 2 plus 5 by 4 into x cube. So is a polynomial or in one variable x. So by definition, what we can see that an algebraic expression in which the variables involved have only non-negative integral power. So here you can see that the variable involved is x and the power of x is non-negative integral power. So they can be only positive numbers. Okay. So in this case, it is an example of polynomial. Let's take another example. 5 plus 4x square minus 7x square y plus 9y minus 1 by 3 xy square. Okay, so is a polynomial in two variables x and y. You can see two variables are there. Okay, then third example is 3 plus 9x raised to the power 5 by 2 plus 5x to the x square is not a polynomial. Why it is not a polynomial? Because 5 by 2 is not a non-negative integer. Okay, so 5 by 2 is not a non-negative integer. So integer are minus 1, minus 1, minus 2 on the left side on the number line. They are negative integers. So what we have to make sure that the variables involved should have non-negative integral power. So these are no, so 5 by 2 is basically, it is positive, but it is not an integer. Okay, because integer are 1, 2, 3, 4, 5, and so on up to infinity. So like that. So if the power is in fraction, so okay, so that will not be a polynomial. So you have to make sure that the powers included in the variables, okay, that should not be negative and that should not be in fraction also. Got it? Okay, so basically 5 by 2 is not a non-negative integer. So if it is a 6 by 2, then we can cancel out and we'll get 3. So that's an integer. But in this case, it is 5 by 2. That will get 2.5 something. So that's not an integer. So it is basically a rational number. Okay. So let's move to fourth one. That is 7 plus 2 into x raised to the power minus 8 plus 6x square is not a polynomial. Why it is not a polynomial? Again, because minus 8 is not a non-negative integer. Okay. Yeah. So these are the four examples. The first and second are the examples for polynomials, and the last two are for the examples for non-polynomials because they are not having a non-negative integral power. Okay. So like this, you can frame a various number of examples. Now, next concept is degree of a polynomial. So the highest power of any term in the polynomial is called as the degree of the polynomial. Okay, so we'll check it once again, the degree of polynomial. Yeah, so the highest power of any term in the polynomial is called as the degree of that particular polynomial. So based on the degree, the polynomials are classified as linear polynomial, quadratic polynomial, then we have cubic polynomial, and then we have biquadratic polynomial, etc. So the degree, you have to keep in mind that the highest power of any term in the polynomial is called as the degree of that particular polynomial. So let's take some examples. The first one we are having, that is linear polynomial. The definition is a polynomial of degree 1 is called as a linear polynomial. For example, 3 plus 7 by 5x. Okay, so here x is of degree 1 because the power of x, okay, that is nothing but 1, because x raised to the power 1 is nothing but 1. So here the degree of this polynomial is 1. Therefore, it is called as a linear polynomial. Okay. Now let's take another example for quadratic polynomial. So a polynomial of degree 2 is called as a quadratic polynomial, right? Then for example, x square minus 4x plus 4. So here you can see that x of degree 2, because the highest power for the variable or a term in this case is 2. Okay, so it is called as quadratic polynomial. Then third, we have cubic polynomial. So a polynomial of degree 3 is called as a cubic polynomial. Okay, we can take an example, x cubed minus 3x squared plus 5x plus 1. So here you can see that the highest power which is present in this polynomial for a given variable x, that is maximum power is 3. Okay, x cubed. So that's why x is of degree 3. Therefore, it is a cubic polynomial, right? Similarly, so for degree 1, we are having linear. For degree 2, we are having quadratic. And for degree 3, we are having cubic polynomial, right? Then we have biquadratic polynomial. A polynomial of degree 4 is called as biquadratic polynomial. For example, x to the power 4 plus 4x square plus 5x. Any example you can make according to your choice. So a polynomial basically of degree 4 is called as a biquadratic polynomial. For example, we can also see 2 minus 5x plus x square minus 8x to the power 4. So here you can see that x is of degree 4, then it is a biquadratic polynomial. So quadratic polynomial is of degree 2 and biquadratic polynomial is of degree 4, right? So you have to keep these concepts in mind. Then we have a degree of a polynomial in 2 or more variables. So the previous examples that we discussed were only about polynomials having only one variable. Now let's check what is the degree of a polynomial if there are 2 or more variables in that particular polynomial. So in the case of polynomials in more than one variable, the sum of the powers of the variables in each term is taken up, and the highest sum so obtained is called as the degree of the polynomial. So to understand this, let's take this example. 5x squared y cubed minus 3xy squared plus 6 minus root 2 x raised to the power 4 is a polynomial of degree 5 in x and y. Let's see how it is of degree 5. Okay, so why it is of degree 5? Because you can see it over here that what is the definition to find the degree of a polynomial having 2 or more variables. So what we have to do, the sum of the powers of the variables in each term. So this is the first term, 5x squared y cubed. So what we have to, we have to take the sum of, take the sum of the powers of different variables. So here the power of x is 2 and the power of y is 3. Okay, so 2 plus 3 will get 5. Okay, so the highest power with the combination of variables that we have to take. So highest over here is in this term, that is 5. So over here it is 2 plus 1, that is 3, and here it is 4. So maximum you can see that we have to take the highest sum so obtained. So highest power obtained is 5 in a combination of variables of x and y. So hence in this case the degree of this polynomial will be 5 only. Okay, then we have monomials, binomials, and polynomials. Okay, so let's understand this concept. So based on the number of terms of the polynomial, they are classified as monomial, binomial, and trinomial, and so on. Okay, so monomial. What is a monomial? A polynomial. A polynomial is said to be a monomial if it contains only one term. So, for example, Harry is having 7 roses, and then it is denoted by 7x. Okay, so here 7x is a monomial because it's having only one term. Then binomial. A polynomial is said to be a binomial if it contains two terms, right? So, for example, Harry is having 9 roses and 5 jellies. Then we form an algebraic expression such as, for roses, we can denote as x. For jellies, we can say y. Okay, so x denotes number of roses and y denotes number of jellies. So 9x plus y is the algebraic expression having two terms. The first term is 9x and the second term is 5y, and we are having two variables also. So it is an example of binomial. Okay, two terms, so that's why we are calling it binomial. Then we have trinomial. A polynomial is said to be a trinomial if it contains three terms. So, okay, for example, Harry is having 8 roses, 6 jellies, and 5 chocolates. Then the algebraic expression is given by 8x plus 6y plus 5z. Okay, so here x denotes number of roses, y denotes number of jellies, and z denotes number of chocolates. Okay, so we got this algebraic expression which is having three terms. That's why it is called as a trinomial. Okay. Okay, then last we have polynomials. So in general, if the expression contains one or more terms. So in general, if you're talking, then if an expression contains one or more terms whose coefficient is non-zero, then it is called a polynomial. Okay. So in general, we call all these expressions are called as polynomials. For example, 4x plus 4xy plus 17xz square minus 10y square z plus 19. So basically, it is an example of polynomial. So next concept is multiplying a binomial by a trinomial. Okay, so in this multiplication, we shall have to multiply each of the three terms in the trinomial by each of the two terms in the binomial. Okay, for example, we are having a binomial that is a plus 4, and we are also having a trinomial that is a square plus 5a plus 7. So what we have to do, we have to multiply each term, okay, each term of the binomial with each term of the trinomial. So if you'll open the brackets, what you will get, we can write like a multiplied by this trinomial, a square plus 5a plus 7 plus 4 multiplied by a square plus 5a plus 7. Okay, so after that, you have to multiply this and open the brackets. So let's see what we are getting after simplification. Okay, so after simplification, you can see that what we are getting, a cube plus 5a square plus 7a plus 4a square plus 20a plus 28. And further, we'll also simplify. So you can add 5a square plus 4a square. So that we'll get a 9a square. Okay, then we'll get a cube. Okay, so a cube is one term plus 9a square plus 27a plus 28. So in this way, we can simplify the multiplication of a binomial by a trinomial. Okay, again, one more example, a plus c multiplied by 2a minus 3b plus c minus 5a minus 2b into c. Okay, so first you have to multiply this trinomial by a and c also. So let's see how we are doing. So in this way, you have to multiply one by one. Okay, and further you have to, after multiplication, you will simplify. So these type of problems we'll also do in our upcoming Zoom sessions. And therefore the final answer that we are about to get over here, that will be equal to 2a square plus 8ac minus 5bc minus 3ab plus c square. So this was all about the multiplication of a binomial by a trinomial. Okay, and in our next session, we'll be continuing with identities, that what basically an identity is. So basically you can see that consider the equality over here, that is a plus 5 into a plus 3 is equals to a square plus 8a plus 15. So we shall evaluate both the sides of the equality for some value of a. For example, let's say a is equals to 8. Okay, so for if a is equals to 10, the left hand side is equals to right hand side, then the above equation is said to be an identity, right? So we can define like that. So this was a brief discussion about the identity also, that we'll discuss in detail in our next coming Zoom coming session. And by the time, you have to just go through whatever you have learned till now in this video class. Okay, and we'll discuss like terms, unlike terms also in our upcoming Zoom session. Based on that, we can perform some simplifying calculations for algebraic expressions and identities. So by the time, you have to just go through this video and watch it at least once or twice, so that you can get a better understanding about the concepts regarding algebraic expressions. And in our later classes, we'll understand that what basically we can do with identities, and what identities we have to learn in this chapter. Okay, so that's all from my side in this session. Let's meet in the next coming session. Okay, till then, take care. Assalamu alaikum to all of you.